Hi everyone, today we're going to talk about section 6.5, which is about rhombi and squares. And after this lesson, you'll be able to recognize and apply properties to prove if a quadrilateral is a rectangle, a rhombus, or a square. So here's some vocabulary terms. Why don't you go ahead and hit pause, and then you can write down the important information from here, focusing on the theorems as well. Okay, so now I'm back. Let's talk about example number 1. It says the diagonals of a rhombus intersect at K. We're going to use what's given to help us find the measure. In this case, we're going to find the measure of the length of KJ. So I'm just going to put a little question mark on our diagram. So we know that FH is perpendicular to GJ. So the triangle FKG is a right triangle. Okay, and that has to do with what you learned about the diagonals. And from here, we're going to use the Pythagorean theorem because we know it's a right triangle to help us figure out the length of our missing side. So we're going to use what's given, substitute 5 in for FK. We don't know KG, and we're going to put 13 in for FG, and then we're going to solve algebraically. Subtract 25 to get, oops, I forgot my squared. Subtract 25 to get KG squared alone. Equals 144. And then find the square root of both sides to find the length of KG is equal to 12. Now, we're not completely finished, but what we did find out is this length here is 12. And so we know, if you look back at your theorems that you just wrote down, because of theorem 6.11, if KG equals 12, then KJ does also. All right, looking at example 2. I'm sorry, we've got a couple other things to look at. So in this case, again, I want you to go ahead and hit pause. There's some information on here, some theorems about the rhombis and squares, and just some specific information about parallelograms. So hit pause and write this information down as well. Okay, now that you have that information, let's take a look at example 2. Example 2 can get kind of overwhelming. It has 11 steps that we're going to fill in here for the 2-column proof. Okay, so let's take a look at this. Our goal, or that we're given, we have 2 bisectors, and we know triangle RMS is isosceles. Okay, and we're going to prove that that figure is a square. So the first thing that I'm going to do in statement 1 is I'm going to write down that SQ is a perpendicular bisector of PR, and PR is also a perpendicular bisector of SQ, and our reason for that is it's given. In step 2, there's 3 things I'm going to put in here. SQ is perpendicular to PR. MP is congruent to MR. And MS is congruent to MQ. And our reason for this has to do with the definition of a perpendicular bisector. Then in step 3, I can say that MS is congruent to MR, and that has to do with the definition of an isosceles triangle. Then MS is congruent to MP, and that's just substitution. So then in step 5, we can say MS, MP, MQ, and MR are all equal. And that has to do with definition of congruence. Okay, our big goal here is that we need to prove that this is both a rectangle and a rhombus in order to prove that it is a square. So I'm going to go to the next slide and we'll finish this 2-column proof. So in step 6, we can say that MS plus MQ is equal to SQ, and MR plus MP is equal to RP. And we can do that because of segment addition. And then in 7, we have that SQ is congruent to RP. Again, this is because of the definition of congruence. So in number 8, we can say that PQRS is a parallelogram, and that has to do from theorem 60.11, which says if the diagonals bisect each other, then we know it is a parallelogram. And then in number 9, we can say that PQRS is a rectangle, and that's from theorem 6.14, which says if the diagonals are congruent, then it's a rectangle. So then in 10, we can say PQRS is a rhombus, and that's because of theorem 6.17, which says if diagonals are perpendicular, then we know it's a rhombus. And so the last one then we can say is, therefore, PQRS is a square, and that's because it's a rectangle and a rhombus. So the key here is just to make sure that you have your theorems out in front of you to prove the different parts in order to prove that it's a square. So let's take a look at our last example. So we have these 4 points. The first thing that I'd like you to do is grab a piece of graph paper and plot out this quadrilateral on your graph paper. And then our goal is going to be to figure out if it's a rhombus, a rectangle, a square, 2 of those things, or all 3 of those things. So I'm going to suggest you hit pause to draw your picture, and then we'll figure out which of those figures it is. Okay, so I'm back. In order for us to figure out if it's a rhombus or a square, we need to see if what the lengths of the sides are. So the first thing that I'm going to suggest that we do is use the distance formula to do that. I'm just going to rewrite our coordinate pairs here. So I've got J is 5, 0, K is 8, negative 11, L is negative 3, negative 14, and M is negative 6, negative 3. So again, we're going to use the distance formula and find the lengths of those 4 sides. So the first one is side JK. 5 minus 8 squared plus 0, or excuse me, yes, plus the quantity of 0 plus 11 squared. So I get negative 3 squared plus 11 squared, which is the square root of 9 plus 121, which is the square root of 130. Okay. Now I'm going to find the length of side KL. Same thing, use the distance formula. 8 plus 3 squared plus negative 11 plus 4. So I've got 11 squared, oops, not negative 3, plus 3 squared, And this also looks like it's going to turn into the square root of 130. So far, 2 of our 4 sides are telling us that they're the same. So I'm guessing that, not guessing, so my speculation is that this is going to turn into either a rhombus or a square. But we still need to prove the other 2 sides. Again, using the distance formula and your coordinate pairs. So we have the square root of 3 squared plus a negative 11 squared. And looking at how we solve the other 2, this is also going to turn into the square root of 130. So again, 3 out of our 4. And then my last side is side MJ. So I've got negative 6 minus 5 quantity squared plus negative 3 minus 0. Okay, and this 2 is going to turn into the square root of 130. Now, since all 4 sides are all the same length, we for sure know this is either going to be a rhombus or a square. Now, how would you think we determine if it's a square? Well, we know squares have right angles. If you think about a shape on a coordinate grid, yep, that's right. We need to find the slopes of the sides. So we're going to do the same thing that we just did. Instead of finding the lengths of the sides, we're going to find the slopes between each of those 2 points, or the slopes of the sides. So again, I'm just going to remind us of our coordinate pairs. So we've got J is 5, 0, K is 8, negative 11, L is negative 3, negative 14, and M is negative 6, negative 3. So again, I'm going to use the formula for slope and find the slope of each side to take a look at it. So I've got 0 plus 11, 5 minus 8, so this is going to turn into negative 11 thirds. 11 over negative 3, negative 11 thirds. Then I'm going to do KL, negative 11, negative 11 plus 14 over 8 plus 3. This is going to turn into 3/11. Well, what do you notice about those 2 slopes that we have? They are opposite reciprocals, so that makes these 2 sides perpendicular to each other, which is a good indicator that this might turn into a square. Again, opposite reciprocals, one's positive, one's negative, and then you flip it over. So let's take a look at LM. We have negative 3 plus 14 over negative 6 plus 3, which as you're looking at it, this is also going to turn into negative 11 thirds. So what does that tell you about LM and JK? They are parallel. So now what we want to do is take a look and find out what the slope of side MJ is. So we have 0 plus 3 over 5 plus 6. So this ends up becoming 11 thirds. So there's a couple things that we notice here. Oh, not 11 thirds, excuse me, that needs to be 3/11. Sorry about that. So we notice MJ and KL have the same slope, so that means they're parallel. And we also recognize that these 2 are perpendicular. Okay, opposite reciprocals. So from here, we recognize that that this is a rectangle. And again, we know it's a rectangle because it has 4 right angles. We also know that it's a square. And we know it's a square because all 4 sides are the same and the angles are perpendicular, or the slopes are perpendicular. And it's also a rhombus. So there you have information on both rhombuses and squares. Best of luck.